In section 9.2, we're going to continue with areas of parallelograms and triangles. On page 559, you will see that the two key concepts are both things you've learned in the past: areas of rectangles and areas of parallelograms. You will notice that in both, the area is the same formula you've used since elementary school: base times height. Now at the bottom of the page, you have three vocab words. It says a base of a parallelogram can be any one of its sides. The corresponding altitude is a segment that is perpendicular to the line containing the base, drawn from the side opposite the base. The height is the length of that altitude. So the altitude is the segment, the height is the length of that altitude. So notice the difference there. The altitude is the actual segment. The height is that altitude. It's the length. So in the first shape, we have the base at the bottom, and I'm going to highlight that in red. So it shows in the book that this is the base. On the same parallelogram, we can also have the base as the other side. Now the altitude, I'm going to put in white, connects from the other base to the bottom base, which I have here in red, and that's a segment that is perpendicular. Now it's an imaginary segment, but it's still there. Over here, I can draw this altitude anywhere I want. It could be there. It could be here, if I just continue this on. It could be anywhere as long as it's perpendicular to the base, which is represented in red. So all of these, no matter what you pick, these are all the altitude. Now the length of those altitudes, that is what is called the height. And so base times height is how you find the area of a parallelogram. So on the top of page 560, we have problem 1, finding the area of a parallelogram. I mean, this is really easy here. We have a parallelogram, and we know the area is base times height. In example number 1, the two sides, the two segments that form the 90 degrees would be your base and your altitude, and the length is the height. So we know the base would be 20, and the height would be 12. So we take 20 times 12, and that gives us an area of 240 squared centimeters. In problem 2, we're going to be finding a missing dimension. So in our got it, it says a parallelogram has sides of length 15 and 18. The height corresponding to a 15 centimeter base is 9. What is the height corresponding to an 18 centimeter base? As you can see, I have drawn this picture. It says we have sides of 15 and 18, and the 15 centimeter base has a height of 9 centimeters. Now the 9 centimeters I could have drawn up here, down here, it doesn't matter. But what I need to find is the height corresponding to the 18 centimeter base. So what you're going to have to do is use the base and height that you already know and find the area. So we know base times height. If the base is 15 and the height is 9, that's going to give us an area of 15 times 9, which is 135 squared centimeters. Now we take that and we can plug it in to this equation right here. And now I know the base, but I need to find the height, knowing that the area is going to be the same. So the area is 135, the base is 18, and we have to find the height. So now we just solve a very simple equation. Divide both sides by 18, and 135 divided by 18 would give us a height of 7.5 centimeters. So let's do example 3 on the top of page 561. So here's the drawing. Obviously the one in the book is much better than what I just drew. We have to find the value of the h for the parallelogram. So that would be the height. Now if you notice, this height here is perpendicular to the base, which is this, which is 10. So 10 and h, the h is what we need to find. But we do know that we have a base of 14 and a height of 8. So we can find the area using that. So the area of the base of 14 and the height of 8, 8 times 14 gives me an area of 112. And that'd be units squared. I then can take that area, plug it in of 112. We know the base right here is 10. We can find the height. So we can divide both sides by 10. And if we do that, we get a height of 112 divided by 10. And that's going to give us a height of 11 and 2/10. And that would just be units, because we are not given a length of measurement for any of our sides. In problem 3, under the got it problem, it asks for the area of the triangle. As we know, the area of a triangle is 1/2 base times height. In this problem, the base is obviously 1 foot, and the height is 5 inches, because those two sides form a 90-degree angle. The problem is that these are 2 units of measurement. You cannot find the area or perimeter of something using 2 units of measurement, so you have to convert this either into feet or into inches. Rather than 1 foot, since I already have 5 inches over here, I'm going to change 1 foot into 12 inches. So the base would be 12 inches, the height would be 5 inches, and now we multiply. 12 times 5 is 60, half of 60 is 30 squared inches. In number 5, if I want to find the area of the triangle, if you look at it, everything is in meters, so that's good. The base is going to be the entire length of the bottom, which is 4 plus 3, that's 7. The height is the 90-degree angle to that, which would be 4. Well, 7 times 4 is 28, and half of that is 14. So the area would be 14 squared meters. In example 4, or problem 4 I should say, not number 4, problem 4, it says finding the area of an irregular shape. So I want you to write down this shape in problem 4 under the got it section.
And this is your pop quiz, brought to you by Mrs. Matson.
All right, so back to the problem. We're going to label tick marks on these 2 sides, and then the bottom as well. We're going to say that these are 90-degree angles. And this is 90 degrees, and there's a tick mark here as well. We're going to label the height of the triangle 8 inches, and we're going to label one side of the square 6 inches. So finding the area of a regular shape. Obviously, as you can see, this irregular shape consists of a square and a triangle. So we have to find the area of a square and the area of a triangle. Well, the square, since the tick marks are all 6, this is just a 6 by 6 square. So 6 squared, or 6 times 6, means the area is 36 squared inches. 1/2 base times height is the triangle. We know the base is the same as, since this is a square, they're all 6. So the base is 6, and the height of the triangle is 8. So that would be 6 times 8. 6 times 8 is 48. Half of that is 24 squared inches. We add both of these together to find the total area, which is 60 squared inches of this irregular shape. Now the got it problem says, reasoning. Suppose the base lengths of the square and triangle in problem 4 are doubled to 12, but the height of the polygon remains the same. How is the area of the figure affected? That means the base is going to be 12. The height, though, is still going to be 6. And the height of this will also be 8. So if we quickly found this, we know the base of this is 12. 12 times 6 would give us 72 squared inches. Plus, this would be 12 times 8, which would be 96. And half of 96 is 48 inches, which gives us an area of 120 square inches. So what we want to know is how is the area of the figure affected? It's doubled. If we go from 60 inches squared to 120 inches squared, the got it problem then would be the area is doubled.